Hello, I'm back. Um, and I wanted to talk about Terrence Howard's latest theory of everything, if that's even what it is. Um, if you haven't seen the joke video I put out already, it's about 11 minutes long. You should watch that, where I basically propose my own theory, which is just as ridiculous. Um, this video isn't about that. This video is I actually want to get into the good parts of it and see if there are some little morsels, nuggets of not wisdom exactly, but creativity that in the right hands could be a stepping stone to truth, or at least to some sort of testable theory or something. Um, and just things I thought were interesting. But before I get into that, I wanted to just give an overview of what my initial impressions were of this. Um, I wasn't even going to watch it, but I had people who had watched it who wanted me to see it and explain if there was anything to it. Because of course, one of my hobbies is I read about physics and stuff, and so apparently they assume I know something. I don't know why they would think that, but so I watched it, and my first impression was, wow, this theory is very wrong. It's a lot of basic facts wrong. Um, in particular, like, you can't just turn one element into another with pressure. They've tried that. you know, you don't just pressure can change the angles of the bonds and stuff. You can change one substance into another. You can cause reactions, but the elements that underline everything, those don't change. You have to actually change the number of protons. And none of chemistry would work, and we wouldn't be able to make all the things we do if we were that wrong about it. My second impression was the guy's crazy. And there's a whole lot of things I can point to, and it mostly has to do with the way he presented his ideas. Um, Number one, he uses a lot of terms incorrectly. He repeatedly used the term angle of incidence, but it had nothing to do with what he was talking about, as far as I could tell. Angle of incidence has to do with, like, you have a wall, and you throw a ball at it, it bounces off. The angle here is going to be the same as the angle here. So there's a symmetry to it. Also, this comes up, you're talking about reflection of light. So if you're standing over here and the light source is here, these rays will get to you. But these rays coming from the light source are going to miss you because they're going to go that way. And these rays going over here will also miss you because they'll go that way. Because the angle has to be equal, see? So, I don't know what that had to do with anything he was talking about when he's got overlapping circles in his flower of life. He also didn't use the word Euclidean correctly. Kept using that a lot. You won't be attracted to Euclidean woman. It's like he's confusing it with flatness and with two dimensions. That's not quite right. Now, sometimes Euclidean geometry is referred to as flat geometry, but that also applies in three dimensions. And the reason it's called flat is because usually the way we think of spherical and hyperbolic geometries in two dimensions is to model them on a two-dimensional surface that's bent into a third dimension. But it doesn't have to be that way. Mathematically, you can still do it without resorting to the third dimension, and there are ways of tiling it. There's another way of visualizing it if the tiles change shape and size away from what you've defined as the center. So, two-dimensional geometry can be Euclidean or spherical or hyperbolic. Three-dimensional geometry can be Euclidean, spherical, or hyperbolic. Same thing above that. Two-dimensional is not synonymous with Euclidean and vice versa. and three-dimensional is not synonymous with non-Euclidean and vice versa. So he badly misused those terms. He also never ties anything in his theory. Well, there's a lot in his theory he never ties to either reality or to other parts of his theory. For example, he talks a lot about the flower of life, and then he's got like the negative spaces in the three-dimensional projection of it. And at one point, he does say one of them is hydrogen, and something else is whatever, the Bose condensate or something. But it's like he doesn't really tie that into what are the ramifications. How would the predictions be different than mainstream thinking? And he doesn't say like these are quantum fields or this is the shape of space or anything like that. And I'm just wondering, like, where are these circles? Are they in our real space, or are they in some abstract space from which our, for reason that we have the forces we do derives from that? Or is it just an abstraction just to think about things, but it's not real? Like, I have no idea where these circles are, what these circles are made of, what they represent, how big they are, and so also his whole multiplication thing, 1 times 1 equals 2, he just like puts that out there, doesn't relate it to the circles, doesn't relate it to chemistry or planetary formation or any of the other things he talked about. Just as a standalone thing. So many things didn't tie to each other or tie to anything in reality. It's not a theory. Whatever this is, it's not a theory of reality. It's more like poetry at best. And I'm being what's the word, generous with that. Uh, um, he also he would go and tie similar words together. He'd be talking about magnets, and all of a sudden he'd segue into talking about magnification and how magnification means to make things bigger. So how can magnets attract? And you know those two words have nothing to do with each other. He did different things like that. He was very jumpy, jumping around all over the place. He's also inconsistent. When he started building up his negative spaces, the smallest one he said was hydrogen, and then he made this bigger one, and I thought, oh, obviously the next one's got to be helium, right? And then lithium, beryllium, boron, carbon. No, the next one he says is the strong nuclear force, and then the first one is the weak nuclear force because it's smaller. And I'm thinking, wait a second, I thought it was hydrogen. Is hydrogen a force? How can a substance be a force? And does that mean everywhere that there's hydrogen, there's a weak nuclear force going on? And anywhere that there's a weak nuclear force, there's hydrogen happening? But that's not what we observe at all. Very much not so. So what is he talking about? And then the third one was crystallization, which is more of a principle. It's not even a force. It's not in the same category as the other forces. It's as different from the other forces as both of them are from matter. And then the next one was like the speed of light. So now we're talking about a velocity. And then the next one was the photon. Well, now we're back to things again, like hydrogen, but it's in a completely different class. And you can't put those in a sequential way, the same way. See, the elements, you can go, there's the number of protons, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, and so on. There's a sequence to them. You can't do that with fundamental particles. Yes, there's the weight categories, like electron to muon to tauon, but how do you compare those to neutrinos? Like, you got the negatively charged leptons, the neutral leptons, the neutrinos. How do those relate? And then you've got 6 quarks. And, and then you've got, the fermions, the bosons, which don't even break down the same way, or have the same number of bosons as there are fermions. It's not like it's symmetrical. It's not really. And now you do have this whole thing is symmetrical with the antimatter, but what do you do first? Antimatter, then the matter, or is it you go back and forth with each one? Like, how would you arrange that into a sequence? And so I don't. He didn't tie it to anything. It's crazy. He also would make like straw man arguments. This is basically he characterizes the mainstream thinkers one way and then attacks that way rather than the reality. So he was always seemed to suggest that they're very tied to Euclidean thinking. But that's not true at all. No, the average person is tied to Euclidean thinking because that's our everyday experience. You can look around and verify that the space we live in is so close to Euclidean that you can't tell the difference. And the thing is, the mainstream model of gravity, which is general relativity, holds that it's actually a warping in space, such that gravity is a slight deviation from Euclidean geometry. Furthermore, they believe that at the smallest scales, space is very jumpy. It's got little dents and bumps. So there's local deviations from Euclidean geometry, but these average out to nothing into Euclidean in scales like bigger than the atomic nucleus. There's also thought that perhaps, even on the large scale, there's a very slight deviation that's cumulative, so that on scales bigger than the galaxy, it might show up. And cosmologists are actively looking for evidence of this. So far, all the evidence points to it staying completely Euclidean all the way as far as we can see, but they're still looking. They take the idea seriously. So this guy's completely wrong, saying that they're really committed to this idea of straight lines and stuff like that. No, not at all. They're really not. And furthermore, there's talk about, I don't even know what I wrote down here. I have my notes. Goodness, I have no idea. Oh, yeah, he also says at one point, they tell us that gravity doesn't exist down at the Planck scale. Then how can, there be, I don't even know what he said, but it's like, no, that's why the Planck scale exists. It's derived from the existence of gravity. Anyways, well, we'll just pass on that one. And then I wanted to quickly talk about his multiplication. Now, of course, everybody knows 1 times 1 is not 2 in normal arithmetic. And even if you were somehow never taught this, if you understand just groups of groups, if you have 3 groups of 3, you can count that. That's 9. If you have 2 groups of 3, that's 6. So now if you just follow the same logic, 1 group of 3 would be 3. And 1 group of 2 would be 2. And then 1 group of 1 would be 1. And, and some people out there, they've suggested that, he maybe meant something else, like he's got a new math system that only has special applications. Doesn't mean literally in arithmetic. Maybe he's using matrix multiplication or rotational numbers or Grassmann numbers or something like that. But the thing is, I know otherwise, because number one, he says this came from an argument he had with his teacher in 3rd grade. He wasn't learning about matrix multiplication in 3rd grade. Also, he says that to multiply means to increase, And that was his problem with it. How can 1 times 1 just equal 1 if it means to increase? Well, the thing is, it doesn't. It's never meant that. Except in very, very, very narrow application, like if you're talking about biology. But that's not what we're talking about when we talk about numbers. Goodness, in biology, cells multiply by dividing. Now, how do you multiply by dividing in numbers? That doesn't make sense. Different meaning of the word, totally different meaning. He also then relates it to money. Now, as anyone who has ever used money knows, anyone who's ever bought anything, ever sold anything, ever been hired or hired somebody, you know that the reason you use multiplication is because it works, not because it's imposed by, like, the Federal Reserve or something. If I'm selling apples at $1 an apple, you expect that when you take an apple from me, you're going to give me $1, right? Now, what if I told you that, hey, wait, it's $2. 1 apple times $1 is $2. So you owe me $2. You'd be like, but the sign says 1. You see, you wouldn't stand for that anywhere else. You'd be like, hey, you're ripping me off. This is false advertising. But for some reason, so the reason people use it is because it actually works. And everyone that's ever done a voluntary exchange knows this. Otherwise, they wouldn't do it. So if anyways. So we know that's not what he meant. Anyways, so now that I've completely destroyed him, I now want to talk about how bad the debunkers are doing. Because I've looked at some of the videos debunking him, and they all do a terrible, terrible, terrible job. They, first of all, none of them went into the detail that I just went in, and I was just running through this quickly. I don't want to do a really long video. In fact, this has already gone on much longer than I wanted, and I didn't even get to the good stuff yet. But they will go on these really long videos where they'll take something he says, just pluck it out of context, and say, I don't know what he means, this gibberish. Well, it's like, well, hold on. Look at the sentence before and the sentence after. That gives clues. So you have a rough idea what he meant. Now, granted, there's some stuff that I still think is gibberish. But some of these mistakes they're making are just stupid. He talked about spectral lines. Like, well, okay. He talked about when you look through a spectrometer at the radiation given off by different elements. Immediately, I know he's talking about spectral lines. And then he says that these two elements are the same, but one is an octave higher. It's like, everything's doubled. What else could he possibly mean other than the distance between the lines is all doubled? Now, is that true? I don't think it is, but you can look it up. But in any case, obviously that's what he's talking about. And then he uses terms like tone and color and he says the same key of E. Now, of course, E is a note in music, and key, that's a musical term. There's some people looking at this, could not figure out what he was talking about. They heard the word color and thought, well, yeah, the elements glow at different colors when you heat them up. Did not hear that he uses spectrometer, did not hear any of the other terms he used, didn't realize he was making a music analogy, and when they heard key of E, they thought he said KeV, or kilo electron volts. And they're like, that doesn't apply, that's stupid. Well, yeah, but that's not what he said. There were other things, too, like, the flower of life. He talked about, he figured out how to open it. Now, one guy's like, you can't open it, it's just a bunch of intersecting circles. You can pull it apart, but then it's just a bunch of circles. And I'm like, okay, think with your brain and not the other end. I mean, it's called a flower. That's not literally a flower, but it's metaphorical. What do you do with flowers? You open them. What does opening something mean metaphorically? Finding the truth in them, understanding it. That's obviously what he meant. You know, he meant it metaphorically. The debunkers are just as stupid as he is, and really, I'm not exaggerating. Like, a lot of them are really just as dumb. Also, now granted, sometimes it's hard to understand him because he said something about, expansion and contraction, and this is what Einstein left out of his theory. Another time he's talking about ether, and he said this is what Einstein left out of his theory. And at first I was like, what is he talking about? And then I realized, oh, wait. He's talking about how there has to be balance. What about the cosmological constant? Einstein originally, he was putting his theory together and of gravity, of general relativity, and he realized that gravity is it's this runaway effect. If the stuff is too close together, it's just going to get closer and closer together until it all gets crushed into a singularity. And the only way to avoid that is if it's all moving apart fast enough to begin with that it has escape velocity, which means they'll just continue to fly apart. So there's no world in which you have a stable world. And thinking, the assumption in the scientific community at the time was that the universe was eternal. It had always been the way it is. And so he actually added a term to his theory, totally unfounded, but it's based on this, what was common thinking at the time. He added a cosmological constant to balance gravity out. But then, later, when Hubble's data came in and showed that the universe was in fact expanding, Einstein realized, I shouldn't have put that in. So he took it out again. That must have been what he was talking about. Now another time he, says he left the ether out. Well, of course he would leave the ether out. It's totally unnecessary, and it was debunked anyways because they couldn't find any sign of it. So, anyways, they're all dumb. The debunkers are dumb, and Howard's dumb. I don't know. Anyways, so I've noticed that. So first of all, I thought he's insane. His theory is wrong. The debunkers are doing a terrible job at debunking them and him. But what's really kind of scary is the number of people pretending to understand what he meant. Now they're not able to explain what he meant, but they keep saying they understood it, and I'm like, I didn't know there was this many trolls. Like, it's going insane, crazy level of trolls. But now, finally, I'm going to get to what I wanted this video to be about, but I had to give a little bit of background. I actually tried to make an earlier version of this video. It ran really long, and in trying to talk about the good parts, in order to explain them, I had to keep talking about the bad parts anyways. So I decided to get them out of the way at the beginning, see how that went, see if this video's better quality. So I'm not like jumping around all over the place so much. So, anyways, this is what I got out of it by actually listening to him and then thinking about it for over a week now, few weeks. Just trying to see if there's any benefit, because even crazy people are very creative. They think outside the box, and they can make connections. They can see connections the rest of us miss because we're too used to just thinking where we're supposed to. They'll see things. Now, most of the things they see will be wrong, won't exist. But every once in a while, they'll make a connection that's like, even if it's wrong, it might inspire someone. They'll say, that's interesting. What if we applied that over here? Or what if we modified it just slightly so that it actually made sense? And then we could test it, So here's what I'm thinking. Number one, this whole planetary formation model, which is like, not that there's clouds of dust and gas out there that then gravity pulls together, which is the mainstream thinking, but that there already is a planet or star, and then a piece breaks off. And then that grows because more stuff gathers to it, but not because gravity's pulling it in, but because it's being pushed from space itself as a pressure, as it's expanding and pushing the matter together. And so it collects more and more, they get bigger. Eventually, it spits off its own babies, which then spit off babies, and so on. So to get this whole process started, there had to have been a primordial planet, I guess. So here's the thing. This is not that different from the steady state theory that was popular back in the 50s and 60s before it was replaced by the Big Bang theory, because they were still trying to hold on to this idea that the universe was eternal, but they knew it was expanding. So they're like, well, is it possible that in this expanding space, small little bits of hydrogen just pop out of nothing, and then enough of it's there just to gather into new stars in the empty space in between. And then, of course, those stars get pulled apart too, but then in between them, more stars form, and so on forever, so that the matter density of the universe stays the same, even though it just keeps expanding and expanding and expanding and expanding, but it's going from infinity to infinity, so what's the difference? Uh, well, the thing is, that's been pretty thoroughly rejected. They found no evidence that hydrogen's appearing out of thin, not even thin air, thin space. It's and so that's been thrown away. But the thing is, like, this variant that Howard has come up with doesn't require stuff, matter appearing out of anywhere. It's well, all right, it still kind of does, because yeah, well, but maybe it's the interaction of the planet with the pressure around it could form it right there too. I don't know, but there's all kinds of you can play with that idea, and then that would be interesting. Now there also about this pressure, and this pressure changing one element into another by applying the right frequencies, and saying everything is frequency. Everything's the same thing, but just has a different vibrational mode. Well, the thing is, that is not too different from superstrings. That's almost what superstrings is. Everything is just the same little strings, about a Planck length long, but they vibrate differently in the 10-dimensional space of superstrings, and that's what causes it to be one particle rather than another. Now, whether pressure can affect that, and what nature would this pressure be? Well, you know what that sounds like? Sounds like the Higgs field. The Higgs field um, um, is basically anywhere you try to move, you run into resistance. And this gives you a resistance to a change in velocity. Well, it's only when you accelerate, I guess. But it's keeps you from moving, and so we interpret that as mass. And of course, anything with mass takes an infinite amount of energy to push up the speed of light. If you don't have mass, though, you're not interacting with the Higgs field. You're just zipping through, but at the speed of light. And he did say something about if you could decouple from this stuff he was talking about, the ether or whatever, you could go really fast. So the thing is, now he did imply you could go as fast as you want. No, you'd still be limited to light speed because of the nature of space. So he's wrong about that, but he's not necessarily wrong about this whole decoupling idea. Although it's not clear how you decouple it and still be what you are. You'd have to turn yourself into light or something. So again, it's not clear, but in theory, theoretically, he's not necessarily wrong about that. He could also have been talking about, Casimir plates. Now, this is when you have two plates of metal and you put them into a superconducting state, it blocks all electromagnetic waves. And because of the Heisenberg uncertainty principle, there's always a little bit of waves of different wavelengths everywhere in space all the time. But this blocks everything for, there's an inside and outside now. And so inside, you can only have waves of this width or smaller. Outside, you can have waves of, you know, as big as the universe, theoretically. Now, the bigger the wave, the less energy it contributes. So we're talking about a very, 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 very tiny amount of energy. But the cumulative effect of all those waves of really long wavelengths, it causes there to be a very slight pressure that pushes the Casimir plates together. So you could almost think of this as the pressure of space pushing stuff together. Now, of course, it's very weak. It only works when it's actually blocking the stuff on the other side because it's superconducting, and that's just the electromagnetic case. So, again, it's not clear what waves he's talking about or how they're being blocked or all of that. See, he doesn't explain anything, and I believe that he doesn't even know what he's talking about. But he's not totally wrong. There is, this Casimir effect. There is the Higgs field, which is just one of the many, quantum fields there are. So there's the electromagnetic field and the Casimir phenomenon, the Higgs field with mass, but all of the quantum fields contribute, and it's so this could apply pressure to things, and could it change the vibrational modes of either a superstring or some variant on the superstring idea? I mean, he tried to apply it to the elements. That's very wrong. Very, very wrong. But on a more fundamental level, could there be something like that? I don't know. But it sounds very interesting. It sounds like, someone could run away with that idea and play with it, maybe make something out of it. Um, Anyways, moving on. He also talked a lot about the flower of life. And it's, these circles that overlap each other, and they end up forming all these other interesting little spaces in there. Where two of them overlap, it's kind of like this shape, and where three of them overlap, it's like this shape. And then he talked about how uh, really it was the three-dimensional version of that. He wanted intersecting spheres, and they make all kinds of different overlapping spaces. And and the thing is, he never really tied this to anything. I don't know where these circles are, what they're made of. What does this have to do with anything? But then something he said once, and I can't remember what it is, but it kind of made me think of, oh, it's kind of like a loop quantum gravity. Kind of like on the fundamental scale of space, he kept saying there's no straight lines because there's these curves here. I'm like, well, wait a second. Hold on, let's think about this. So, here's the thing. On the smallest scales, okay, so here's the thing. The amount of your wavelength is inversely proportional to your energy. The very low energy particles have really long waves. If you have a really high energy or high mass particle, same thing really, it'll have a very short wavelength. Now, at some point, your wavelength is so small and your mass is so big that there comes a point where the relationship is such that you have such a high density there, all that mass in such a small space, that it becomes a black hole, makes an event horizon around it. And what this does is, well, for one thing, nothing can get out. So this is kind of the maximum amount of energy you can put into something. You try to put more into it, you're just going to make the black hole bigger. And the bigger black hole is, the less dense it is. So this is sort of a cutoff point. And so it's thought that anything below that size is meaningless, because it's like everywhere. If you if you try to, if there was any reality to anything that small, it would just be cut off from our existence. It wouldn't exist as far as we were concerned. And so, um, So we only deal with things bigger. So it's like there is no smaller space, and so, it's almost like and particles a lot of times are thought of as just being infinitesimal points, but in this case they would have to be spread out over that area at best, and or at least they'd have to be spread out over that volume, and then in quantum loop gravity they add another stipulation to this where it's like these regions are not continuous, but they're separate space-time events connected by little struts. They draw like a diagram. They call it a spin node network. Now, and there's no space. This doesn't exist in space. This is what our space derives from. There's actually no existence between. It's just there's this space-time event, then there's this space-time event, and they connect to each other a certain way. You can only get from one to one that's connected, and so then I thought, well, all the pictures I've seen of these, they're two-dimensional and they're amorphous. They're not, rather than crystalline, they're not regular, and they're pretty random. And I'm just wondering, what would happen if the correct model of the spin node network of quantum loop gravity was these intersecting spheres. Now, I don't know whether each like section on the surface of the sphere or or the whole sphere would be like the space-time event, or just the vertices where they connect, or whether it's the edges or the struts or whatever it is that is these events, and the way they're connected is how they connect. Um, uh, and I don't know what the implications would be of this, how it being different from what they normally predict. But I wonder if there would be some benefit from having them in that shape, or some other shape. Play around with the shape of it. Could that lead to anything? I'm just throwing out creative ideas here. And now as for it like overlapping in different spaces, maybe like this event, you can't go from this space-time event to this one, but you can go sideways, right? So, but you have another. You can also jump over it. Like some of these, the circles touch. There's another circle in between, but you can't go there. Maybe you have to go sideways to then go around and get onto that circle. So, again, I'm just throwing out ideas. And so, in this sense, you say there's no straight lines at the smallest scale, and you also, I don't know what the implications would be. But then, of course, he went further because he made a big deal of these negative spaces, and I didn't really get what he was getting after. But the shape of them, there was concave and convex surfaces. I try to say like the concave represented compression, and the convex, like the points, that was expansion. And of course they're not. It's just a shape just sitting there. Nothing's expanding or contracting. But then I thought, well, but the geometry of it, like if this is geometry of space, then it's kind of like this could lead to forces, like the way gravity is thought of as a bending in space. Maybe you could derive a force from this of some kind, and then of course the way these different negative spaces were combined, they would be kind of everywhere because this whole spin node network is everywhere. But this is like the shape of the quantum fields at every point. And so there's the geometry of space itself at every point, which would lead to these different forces and these combination forces. And you think, what is a force? It's a combination of uh, repulsion and attraction, which you can think of as a subset of expansion and contraction. Now, yes, there's also the weak nuclear force, which changes one kind of particle into the other, but maybe there's a way you can work that in somehow in terms of this. Maybe one particle is further away in some sort of abstract internal space or something. I don't know. But um, then this could lead to a theory of everything, because basically covers the actions of all forces, even if it doesn't. He never described the specific forces. Now, yeah, I know he then built this whole linchpin thing where he just randomly pointed at struts and said, "This is this force and this is this force." But it's like, what? No, that doesn't make any sense. That's just that's just a whole bunch of these things in a row. What's going on in between, and how is that, a force? And it looks the same to me. It's just, I mean, it's crazy. So, anyways, um, so this would provide basically unified field theory. So the thing is, it also seemed to make a big deal of like they got electricity and magnetism wrong. Made a lot of things. Oh, we think of magnets as attractive, and I'm like, no, they're repulsive half the time. It has to do with which poles with which pole. He was talking all around in circles. He was crazy. But here's the thing. So we we understood electricity separately from magnetism, and then figured out they were part of the same underlying force. And it was also merged with light. We realized that was a electromagnetic phenomenon. And then later we merged the weak nuclear force with that, made the electroweak theory, and then later we tried working in the strong nuclear force, somewhat successful. And of course, electricity was like, we know sometimes things stick to other things, sometimes there's a static discharge, and then there's lightning. There was a time they didn't know that those were connected. So it's been a process of unification. And then with gravity, too, they knew that when you used a catapult to take down a castle, that the thing would go in a particular curve, and they knew that the planets were going around like this, but they never connected them until Newton came along. And so it's a trend to unification. So, but once you get to complete unification, you could break it down a different way. You could think of it in a different way. Think of every case of repulsion one way and every case of attraction a different way. I mean, it'd be kind of weird uh, way of thinking about it, because it would be mixed. You'd have like a single, two magnets, which sometimes you arrange in one way, they're doing one force, a different way, it's a different force. Why would you think of that as two forces? But you could, depending what you do with it. But anywhere that it manifests, anywhere there's attraction, two magnets attracting Earth attracting the moon through gravity, or whether it's electricity, where there's like a positively charged surface and negatively charged surface sticking to each other. You could just think all attraction is the same underlying force in everything attracting, right? So you could try to have some sort of framework like that. And it sounded like that was where he was going, although it was really hard to tell because, like I keep saying, he was jumping around like a madman. And so I'm wondering if think about forces in different ways. So this is, my suggestion. And one more thing before I tie this up. He made a big deal about there's no straight lines, because there's this curved lines in his circles. That sounds, well. Here's the thing. There's no line in nature that's perfectly straight. There's always some deviation, but there's also no such thing as a perfect circle either. So, and this is where some of the people in the comments, the people both debunking him and supporting him, are getting into this argument of where this is going. The thing is, like, you can equally say both ways. You can say straight lines don't exist because they're never perfect, so it's all circles. It's all waves of energy, which are sine waves, not hemispherical waves. Which he had circles, not sine waves. Big difference. They're not polynomials. They're not parabolas. They're, anyways. uh, forget where I was going with this. Yeah, but you could equally say it the other way. You could say that there's no circles if you look really closely. It's actually all straight lines. So, and that's very similar to the digital versus analog debate. What is the fundamental nature of reality? We don't know. Is it digital or analog? Like, the fundamental units of information, is it like all or nothing? Is it first, it's either here or there, but there's nothing in between? Or is there, mixing? Is it everything possible? And that's not just in space. I mean, I get it that way, but I like jumping between different values of something. Maybe is information ever destroyed or lost? Now, of course, in quantum mechanics, it's not. Information is conserved, but we already know quantum mechanics is incomplete. For one thing, it might be based on some underlying thing like cellular automata, where like changing the state of one pixel depends on the nature of the pixels around them, and so things spread and stuff. Now you got information actually being created and destroyed in those situations. That's what the underlying mathematics would be. We have no idea. So are all curves really made of straight lines? Or are all straight lines really made of curves? Or maybe it's both. Maybe it's fractal all the way down. Maybe we're both right. So these are things that are not known, and be interesting to find out. And this is stimulating, like Howard's whole thing here is actually stimulating that kind of thought. So anyways, so now to wrap this up. So physicists, I want them to be thinking about, like, is reality digital or analog? Are there any straight lines? Like, are there any curved lines? What is the deepest, fundamental stuff? One to think about. Can you think about the forces broken down differently? Does that lead to any insights? Like, thinking of it all as like attraction is one thing, contraction and expansion is the other, or and can you and is there any way that the spin node network or some variant on that idea could give rise to sort of the shape of space too, at its fundamental, the kind of the geometry that leads to what the quantum fields look like and how they interact. So something on that level, and could there be any sort of pressure on either superstrings or at some other level that would change one type into another? Like, not like one particle just hitting another and changing it, because of course that happens. But I don't know. There's something more like pressure. And then I guess no one cares about the steady state theory, but that's it's interesting that we still don't have a good theory for where elements heavier than iron come from. It used to be thought they were in supernovas, but then they changed it and said, like, it's when neutron stars collide, parts break off, and then they decay rapidly into more stable arrangements in smaller nuclei around these big chunks of neutronium. And so at least there, it's like those did break down they were spit off that way. So even if he's wrong about planets and stars, could he be right about some narrow part of the universe? I mean, look at biology. No one knows how to make a living cell out of pre-living stuff. No one's figured that out. It's like it takes a cell to make a cell. So I don't know. Play around with those ideas and see if you can find any connection there. And good luck. So anyways, this is my take on it, because I am Dan. This is what I do. I try to redeem things, find the good in the bad, and I'm creative, and I just I look at things from different perspectives, try to come up with some crazy ideas of my own, and I already have a blog at chartingpossibilities.com. I'm sorry, chartingpossibilities.substack.com, and where I talk about culture and politics, and but also physics and religion, and I put some of my poetry on there and other thoughts about things, and so um, go check that out. I also write science fiction stories. Just started another Substack at championofthecosmos.substack.com. I got a shirt made for it. I don't know if you can see it. Champion of the Cosmos. Let's get up here. I can't do it. There's not enough space. There's not enough space. See? The most epic series of all space-time. Ow! Championofthecosmos.substack.com. I'll be putting, starting early next year in January, I'm going to be putting out one story a week. That's my plan, anyways. and I've got like 30 years to go because I got this whole series in my head. At least 3/4 of the stories I already have ideas for, and I've just got to write them down, and it's hard to find time in the middle of life. But that's what I'm doing. Right now, I already have chapters from my book, Spider, the Witch, and the Spaceship, which kind of introduces the whole series. It's not the first episode, but it takes place in Nate's adult life, where he's looking back on his childhood and remembering his very early childhood. And so it is kind of an introduction to the first few seasons are going to be his childhood, and then after that, he's going to be an adult, and the world's different, so and in the science fiction series, of course, I'm always exploring possibilities of existence in science, and so the two blogs are basically like mirror images of each other. One is through storytelling and fiction, I chart possibilities, on Champion of the Cosmos, and but then over at Charting Possibilities, I talk about philosophy and stuff about the real world. And so, anyways, that's who I am and why I did this. And I had a lot of people suggesting I do this, pressuring me into doing it almost. So I finally decided to do it. Anyways, thank you for watching, and I'll see you again sometime. Peace.